Assalamu alaikum. Dear students, today our topic is thin lens in contact. We will see if two or more than two lenses are placed in contact, what will be the focal length of the combination of lenses and what will be the power of the combination of lenses. And when the two or more than two lenses are placed in contact, the lens is known as the equivalent lens and their focal length is known as effective focal length or the equivalent focal length. Now look at dear students, consider these two convex thin lenses of focal lengths f1 and f2 placed in contact as shown in figure. Now we will see what will be the focal length or what will be the equivalent focal length of the combination of lenses, or when the two are placed in contact or three, the lens is known as the equivalent lens. Here let O be the point object placed on the principal axis of the lens in contact. Look here, O is the point object. Now after refraction here, look, if the second lens was not present, that means there is only one lens, then the first lens forms the image of the object at I1. We consider that the second lens is not present, then this lens, that means whose focal length is f1, forms the image I1 of the object O at the principal axis at a distance v1 from it. Present, then the first lens forms the image I1 of the object O at a distance v1 from it. That means when the rays of light pass through first lens, if we consider the second lens not present, then this lens, whose focal length is f1, it will form the image of the object at I1 from the lens whose distance is v1. Now from lens formula, what is object distance is u, image distance is v1, so it is minus 1 by u plus 1 by v1 is equal to 1 by f1. Why f1? Because focal length of the first lens is f1. Now, dear student, as we know, there is second lens which is placed in contact with the first one. So this I1 acts as a virtual object for the second lens. I will repeat it. The image I1 formed by the first lens, it acts as a virtual object for the second lens, and it forms the image I1 of this object at a distance v from it. So I will write it here. Since the second lens is in contact with first, so I1 acts as virtual object for second lens, which forms the image, I at a distance v from it. Therefore, minus 1 by v1 plus 1 by v object is 1 by f2. This is second. Now we will add first and second equation. Adding equations first and second, we will get. What we will get? We will get minus 1 by u plus 1 by v is equal to 1 by f1 plus 1 by f2. minus 1 by un and plus 1 by u cancel out, so we will get minus 1 by u plus 1 by v equals 1 by f1 plus 1 by f2, or minus 1 by u plus 1 by v is equal to 1 by f, where 1 by f is equal to 1 by f1 plus 1 by f2, or here f is equal to f1 f2 divided by f1 plus f2. Now dear students, look here, what is this f capital F? It is the equivalent focal length or the effective focal length of the combination of lenses, and it is equal to f1 f2 divided by f1 plus f2. Which is the effective focal length or equivalent focal length of the combination of lenses. That means the equivalent focal length or the combination of lenses is equal to this f1 f2 plus f1 by f2. Now these two lenses which are placed in contact, they are known as the equivalent lenses, and their focal length is known as equivalent focal length or effective focal length. Now dear students, if there are more than two lenses in contact, what will be the effective focal length or what will be the equivalent focal length if there are more than two lenses? If more than two lenses are placed in contact, then what will be the focal length? It will be 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3 plus then so on and so on. That means that if the number of lenses increase, it will be the effective focal length 1 by f1 plus 1 by f2 plus 1 by f3. Now what will be this is the effective focal length. What will be the power, equivalent power of the lens? Equivalent power of lens. As dear students, we know the power of lens is given by E is equal to 1 by f. Now if two lenses are placed in contact, then equivalent power of lenses is given by P is equal to P1 plus P2 if more than two lenses are placed in contact. Then what will be the equivalent power? The equivalent power will be P1 plus P2 plus P3 plus P4 plus Z. That means the power of the equivalent lenses is the algebraic sum of the powers of the individual lenses placed in contact. That means the power of equivalent lens is the algebraic sum of powers of individual lenses in contact. This is how we find the equivalent focal length of the lenses when two or more than two lenses are placed in contact, and what is the equivalent power of the lens in contact. We have derived both the equations. The equivalent power is given as the algebraic sum of the powers of the individual lenses, and the equivalent focal length we know is given by f1 by f2 divided by f1 plus f2. Thank you.